In this video, we'll be discussing acid rain, how it happens, and what we might be able to do to mitigate the problem. So here we have some diagrams depicting how acid rain occurs step by step. So first of all, what is acid rain? So acid rain refers to any kind of rainfall with a pH lower than 5. And as a quick review of pH, the pH scale runs from 0 to 14 and measures whether a substance is an acid, which is 1 to 7 typically, neutral, which is 7, and then base is then all the way up to 14, going up from 7. So as you might expect, acid rain is going to have a pretty low pH, generally lower than 5. So the reason why we have acid rain is because of the pollutants that are present in the atmosphere. And these pollutants are typically a result of compounds that we eject into the atmosphere from factories, coal plants, vehicles, and the like, typically created by carbon dioxide emissions, for example. And so what we have present in the air as a result of all these pollutants is sulfur dioxide. And this actually appears down here. This is a molecular 3D model of the compound sulfur dioxide, or SO2. And we have, you can see the central yellow is the sulfur, and we have the two oxygens branching off to the side. So, the reason why we have acid rain is because we've got this sulfur dioxide here in the air, and when the rain falls through and merges and combines with the SO2, you get an acidified particle because the SO2 results in the rain becoming acidic. And because SO2 readily converts to this here, SO3, or sulfur trioxide, you get an even more dangerous compound in terms of acidity, because when you combine sulfur trioxide with water, you get sulfuric acid as your final product. So this here is the monstrous compound known as sulfuric acid. And it's in the name. This is a very strong and very corrosive acid. So when this is combined with water that's usually part of rainfall, what you get acid rain. So that's how you get this problem here involving acid rain. So in this diagram, we can see step 1, we just explained, is acidified as it falls to the air. Then step 2, the acid rain, of course, is going to fall down to the ground. But not only that, it's going to enter lakes. And it's acidified, so it enters the lakes as acid. You can see here the H3O plus, or hydronium. That means it's an acid. It's entering the lake right here. And what you're getting is you're getting hydronium in the water. And as our third step here, most lakes actually contain a compound called calcium carbonate. It's this here, CaCl3, also known as limestone. And this special compound is able to actually neutralize the effects of acid rain because this is a base, so it cancels out the effects of the acid rain. And because this is so present in lakes, the effects of acid rain really aren't that pronounced when you have bodies of water like this. And here is a complex chemical formula showing the complete process here. We've got the hydronium, which comes together with the limestone, and it kind of breaks it down and neutralizes it. We only have water, we only have carbon dioxide, and only some positive ion calcium. We completely eliminate the acidic calcium carbonate due to the limestone, which helps to kind of clear it out. Now here you can see in lakes where there is no limestone, you're in trouble. As you can see, our tree here has completely died due to the issue, and we only have granite rock in this lake. That's not going to do anything. We just have the acid rain, the hydronium, coming down from the sky and collecting in this lake with nothing to clear it out. So, and this harms the ecosystem, destroys the plants, destroys the river, the lakes, all of it. It's a big problem if you don't have limestone, as you do here. Okay, so ultimately, the battle of acid rain comes down to this. We've got your limestone here. This is the 3D model of limestone for reference. And that's trying to keep out all of our harmful compounds. The sulfuric acid is trying to neutralize. And it's an ongoing battle that's always happening. And it can only happen if you have this here limestone present in your lake. So, of course, there are some better and more long-term solutions to preventing acid rain than just sprinkling limestone in every lake, which is very costly and hard to do. Ultimately, the best solution to the problem of acid rain is to simply eliminate or switch away from the harmful pollutants we are currently dumping at massive rate into the atmosphere, like carbon dioxide and sulfur, sulfuric acid, SO2, SO3, all of this. But that is very difficult as well to switch away from it entirely, even though that's the only really feasible long-term solution to the problem of acid rain. And there we have it, the complete picture of acid rain and some possible solutions and how acid rain forms, the chemical perspective.